Hello, good day viewers. In this tutorial, we are going to evaluate these two limit problems. You can see them right here. The first one, we are asked to evaluate the limit of the function 1 divided by x minus 3 all squared as the value of x approaches 3. While the second one is a piecewise function, we are given a function g of x and we are asked to evaluate the limit as x approaches negative 3. And you can see the function here. It is x plus 5 when x is less than negative 3, and it is 2x minus 1 when x is between negative 3 to 4, excluding 4. All right, let's get started. All right, let's start with the first one here, where we want to evaluate the limit as x approaches 3. Let us direct substitute and see what happens. If we direct substitute x equal to 3, we have 1 divided by 3 minus 3 all squared, right? 3 minus 3 is 0, 0 squared is 0, so this is the same thing as 1 divided by 0. You should know that when you're talking about limit, this is not undefined because x is not equal to 3 directly, but approaching 3. So this will tend to approach infinity. But which of the infinities? Is it positive infinity or negative infinity? You should know that the denominator is positive because of this power of 2. Therefore, the whole limit will approach positive infinity. But you can check the left and the right hand side limits to confirm. Let's do that. Suppose we want to evaluate the limit as x approaches 3 from the left hand side of this function, 1 divided by x minus 3 all squared. And you want to also evaluate the limit as x approaches 3 from the right hand side of the same function, 1 divided by x minus 3 all squared. Let's do them separately. Suppose we have a number line here where we have our 3. If we want to approach this 3 from the left hand side, we have x approaching 3 from the left hand side. It implies that x is less than 3, right? All the values of x are less than 3, which implies that x minus 3 is less than 0. This means that this is x minus 3 is negative. But if it is negative, if this is negative, power of 2 will transform it to positive. Therefore, this will approach positive infinity. The same thing, if you're approaching this from the right hand side, x must be greater than 3, and x minus 3 is what? Greater than 0. You see, this is already positive without squaring. So in either way, we are going to approach positive infinity, and you can look at it graphically. If you graph this, this is y-axis, this is x-axis. You know we are going to have a vertical asymptote at what? X equal to 3. Because we don't want the denominator to be equal to 0. So at x equal to 3, if this is 3, you're going to have a vertical asymptote here. And if you construct the graph, you're going to obtain something like this. Something like this. As you approach 3 from the left-hand side, the curve will deflect towards positive infinity. Likewise, from the right-hand side, it will tend to approach positive infinity. So in either way, you're going to approach positive infinity. Now let us look at the second problem. All right, here is our piecewise function. We would like to evaluate the limit as x approaches negative 3. So let us first of all look at negative 3 on a number line. Suppose we have a number line here and we have negative 3 here. We want to first of all evaluate the limit as x approaches negative 3 from the left hand side. If we have this, it means that what? X is less than negative 3. And where do we have this condition? X less than negative 3. It is exactly here. Therefore, we are going to substitute x equal to 3 in here, right? That's our left-hand side limit. So for our left-hand side limit as x approaches negative 3 from the left-hand side of this function, g of x, will be equal to what? Negative 3 plus 5. because we are going to substitute it here. And this will give us what? 2. Can you see that? Then what about the other one? As we approach from the right hand side, x will be greater than -3. And where do we have this condition? This is exactly where x is greater than -3, and hence we are going to substitute it here. So for the right hand side limit, as x approaches -3 from the right hand side of the function g of x, it will be equal to, we have 2x minus 1, right? So we have 2x is -3, then we have minus 1. This is -6, -1, and this is equal to -7. So what you should observe here is that the left hand side limit is not equal to the right hand side limit. Since the limit as x approaches -3 from the left of this function g of x is not equal to the limit as x approaches -3 from the right hand side of the same function, we say that what? The limit does not exist. The left and the right hand side limits must be the same for that limit to exist. And hence the limit of this piecewise function does not exist. Unless if you're asked to find the limit of a particular side, whether left or right hand side. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.